Okay, can you hear me okay? Yeah? Good. So I think I may be the only thing that remains between you and a well-deserved break. So I really appreciate your coming this morning. And so we'll be looking at policy trying to address the climate and the other environmental issues. So I'll be focusing on two topics. One will be a bit general. What are the instruments for policy that is trying to help with the environment? And then we'll talk about something a little more specific, which is the integrated assessment modeling approach. And you'll hear what that is about. So let me right away talk about how we think in terms of very broad terms about why and how we can do something about the environmental problems. So the basic graph that especially economists have in mind when they think about these issues is this graph. And so on this graph, you have something that's important to understand, and that's on the title. It's about, everything is about the margin. So what does that mean? So when people make decisions about a certain thing, so it can be any kind of action, a quantity, it can be buying something, or it can be driving some miles with your cars and things like that. When they do that, they balance the benefits and the cost. And if everyone does it on his own, these are the private benefits and the private cost. So this looks very much like a sort of demand and supply curve that you have on a market equilibrium, but it can be a bit general. It can even be just your own decision. When you decide to do an extra trip to visit your mother, what kind of cost and benefits do you balance, right? So you think of the cost, you have to pay something to pay for the trip. You may think of additional costs, so it might be that an extra mile brings an additional bit of exhaustion and this sort of thing. So it might be that the cost you are thinking of is increasing. So that's the marginal cost. So it's the cost of the last unit. So this cost may be increasing the more you do, for instance, driving on the road. And you have the benefit, and the benefit may decrease. So when you visit your mother, it may be very important once a month, twice a month, and so on. At some point, your mother may start to think that it's a bit too much, and you may feel the same as well. And so the benefit of the extra visit may decrease. And so when people make the decision on their own, what typically happens is that the last unit they decide to take in terms of quantity will equalize the cost and the benefit of this last unit. And that's what we call the marginal cost and the marginal benefit. So the equilibrium notion here means that's where we are spontaneously when people make decisions on their own, right? But that may not be optimal because it might be that their action has some impact on other people. So if you think of externalities or things like in the commons problem, when you do have impact on the others because you overuse the resource, you have something to add to the private cost, which is the social cost. And the social cost represents your impact on the others, all the others who have no say in your decision, right? That's the thing. The people who can't intervene, who can't influence you, you are on your own, you make your decision, and they don't have a say, but they may bear the consequences. And so if you drive an extra mile, the people who will be born in 200 years and will suffer from climate change, for instance, will bear the consequence of that extra mile that you've driven with your car. And so the difference between these two curves represents this marginal extra cost. So we call that the social cost. Social because it's about society bearing this cost, right? So it's a large cost. And so the real thing, the point we would like to get at is not this point where we only take account of the private cost and benefits. We would like to take into account everything. And so the optimum would be at the intersection of these two curves here. And you see these, when we have a social cost that is added to the private cost, the optimum represents a smaller quantity, right? So we do too much of the things that have a social cost on the others. And there is a similar graph when you think of public goods, contributions to public goods. What happens then is that you have extra benefits to other people. When you contribute to a public good, other people will benefit. And so I'll let you do it for yourself. Try to look at what happens when you have a social benefit. So you have an extra benefit that has to be added to the private marginal benefit. And then what you see is that the equilibrium is too small in quantities, and we need to encourage we need to encourage that. So that's the configuration. Is there any question about that? If you understand that, you've understood half of what I have to say, in a way. Everyone okay with that? Yeah? Great. Yes?
My takeaway from what you just said is that the equilibrium there is just considered private interests, right? And that's not where you want to be, the ideal of optimum.
Right, exactly. Yeah, yeah. And why do we have the equilibrium here? Because without coordination, people just look at the private cost and benefits, right? So we need some kind of coordinated action to look at the social cost and the social benefits. And how can we do that? That's the topic of the first part of this course. So how can we make people internalize? How can we put the social cost in the computation of private actions, right? So you have various instruments. So let me list them a bit quickly and mention some elements about them. So Pigou is the economist whose name is associated with the idea of using taxes and subsidies. And so I said taxes and subsidies, including for negative externalities, because you can tax, right, the things that produce negative externalities. You can tax that, but you can also provide a subsidy and reduce the subsidy if people emit or pollute too much, right? So you can say, I give you this subsidy, but if you produce too much externality, I will reduce the subsidy. And so the reduction of the subsidy is the same thing in terms of marginal calculation. Having to lose a subsidy is the same thing as having to pay a tax, right? So what counts in this kind of computation is always at the margin, okay? So that's why it's not so much whether it's a tax or a subsidy. What matters is what do you pay on the extra unit. So you have to pay something on it, and it can be a tax or it can be a reduction in a subsidy. So when you use this instrument, the key question, the difficult question is what is the right level of these taxes and subsidies, right? What is the level at the margin, again? The other instrument and the name associated to that is Ronald Coase, an American economist, is the cap and trade mechanism. So the idea here is you determine the total quantity you want to allow of these externalities. Okay, so if you go back to my graph here, you say, okay, we know where we want to go to. The total quantity is here. So let's say that's the total quantity we allow. And we'll grant permits to people that correspond to this total quantity, and people will be able to trade so that they allocate between them the allowed quantity, and the price of this thing will be endogenous, will be formed on the market. So it's a sort of dual to the tax mechanism, because in the tax mechanism, you define, the government sets the price, and the quantity is determined by people's actions. In the cap and trade mechanism, the government sets the quantity, and it's the equilibrium on the market for permits that determines the price, that determines the tax, essentially, right? So paying for a permit is the same thing as paying for a tax. So essentially, the level of the tax now is endogenous, and it's the total amount that is decided by the government. And you have an extra problem with this thing, which is how do you distribute the permits, right? To who do you give the permits? So you can use taxes and subsidies also on investments, on inputs, on the means to reduce. So for instance, you can subsidize R&D in green technologies. So that's another kind of policy that can be used and is playing on a particular kind of actors, right? It's targeting the actors that can help with developing new technologies. So it's very specific. And you have regulations and norms, for instance, energy efficiency norms for motor vehicles and engines and this sort of thing. So you can impose norms. And there is a sort of, this is a fraught issue. You have a sort of debate between the economists and the non-economists over these. So the economists tend to dislike these command and control mechanisms, regulations and norms. So why is that? Well, economists tend to dislike that because it's very hard to essentially impose norms at the local level, at the macroeconomic level to every agent, so that the norms fit exactly every local situation. The advantage of using taxes or cap and trade is that the agents can adapt and they can somehow reallocate among themselves the thing. So when you face a tax, you adapt to the tax. Everybody pays the same tax, but for them, for some of the people, paying that tax means changing their behavior a lot. For some people, it means changing their behavior a little less, and they adjust to that, and that has some some efficiency properties in terms of reducing the total cost of these operations. Whereas if you impose a norm, usually the norm has to be more or less homogeneous. It's very hard to tailor the norm to local situations, and that may be problematic. But there is a but. I want to say that we should not be dogmatic about that, because there have been, for instance, experiments where some cases, and the most famous experiment has nothing to do with the environment. It has to do with kindergarten parents coming to pick up their kids too late in the afternoon. And so there was a sort of norm that was you shouldn't come later than this time. And if you did, you were looked upon in a bad way. And then they said, well, people still abuse this, and so we'll impose a fee on the people who come late. And as soon, so a bit like a tax, right? A bit like a pigou tax on being late. And as soon as they did that, then more people were late. Why that? Well, because now it was okay. You just had to pay a fee. You were not frowned upon. People just thought it was totally okay to pay the fee and be late. And so there is a problem of the expressivity, the expression through the policy. So if you say you just have a tax to pay, it means it's okay, you do what you want, and you pay the tax and you are off the hook, right? Whereas if you say it's forbidden to do that, then people feel a bit more restrained in their attitude. And so there is a behavioral issue here. What's more effective? It may depend on how people view these things, and there is an expressive value in these policies. And that's why the last item here is there. Education and moral education. Morality injunctions can play a role in people's behavior in addition to incentive mechanisms. So I don't know how familiar you are with the Green New Deal initiative. It's a set of goals. It doesn't propose any, it doesn't select the instruments here. But as soon as it was sometime after it was proposed, it was announced, a group of civil society movements wrote to the Congress saying, we have precise demands about how the Green New Deal initiative should be implemented, and it should not use market pricing mechanisms. We have a very strong demand on that. No taxes, no cap and trade, right? So these are bad instruments. And so there is, you see, the political debate is really fraught between those who hate these pricing mechanisms and those who think that they are the most efficient. So yeah, be aware of these debates. Another issue that I want to briefly mention is this problem of the polluter pays principle. So it's very natural, and actually it comes from the OECD, so it's kind of mainstream idea. The idea the polluter should pay, because the polluter somehow is the guilty party here. In fact, what the analysis really tells you when you look at this is that, yes, efficiency, if you want to go to the optimum, requires that the polluter pays for the last unit of pollution, right? So internalizing the externality means that the social cost must be put as added to the cost at the margin, right? But as I said, this cost at the margin can be a reduction in a subsidy, right? So in terms of the total money that's transferred from the government to the person, it might actually be still, the polluter might still receive money, right? And might receive less money if he pollutes more, but he would still receive money. So we should distinguish between efficiency, which says, yes, the polluter should pay at the margin, and fairness, which is about, yeah, who should pay in total, right? Should we subsidize people to help them, or should we punish them? And that's where fairness is relevant. And you can look at that when you choose between a tax or a subsidy, and when you look at how to use the proceeds of the tax, and also when you do a cap and trade mechanism, as I said, you could give the emission rights to any party and then let people trade. So if you give the rights to poor people, then you will take account of social issues on top of environmental issues. If you give the rights to rich people, you might compound social problems with environmental policy, but that's up to you. That's a fairness consideration. Okay, is that clear? Yeah? Any question or comment on that? No? Okay, great. Let me give you a few examples of where we are. So there is a famous success story in the US for cap and trade mechanism. That's the thing that was connected to the acid rain problem. So the sulfur dioxide pollution that was mainly due to power plants, especially coal power plants. And there has been an amendment to the Clean Air Act in 1990 that introduced a cap and trade mechanism. It has worked wonders. It has been quite successful in reducing the emissions. Here you have the emissions, in reducing the pollution. And people didn't think at the beginning that it was not just about the health of ecosystems, it was also good for the health of people. And the reduction in pollution has actually been very sizable in terms of improvement of air quality for human beings as well. So co-benefits were quite important. Now, what are the features that made this work? So when people look at that, they say, well, it worked because it was pretty flexible. So it was not a sort of extremely punitive policy on these plants. So there were some free allowances given to them, right? So that you give the allowances, it can be free or it can be auctioned. So there were some free allowances to avoid that this was a big cost for them. There was some grandfathering. So you know what grandfathering means? It means you look at what was the status quo before the policy, who was polluting more, and you give more rights to these people. Again, because you don't want them to create a rebellion against your policy. This was a political savviness in the story. It was not essentially a fairness issue, but it was mostly a political expediency. And they were quite flexible about the targets. So when they realized that the targets were working very well, they reduced the targets relatively quickly. And so that was well done. But there was also a favorable circumstance, a favorable context. The technology to deal with that was there. The scrubbers were already available as a technology to filter the emissions. There was the possibility to buy low sulfur coal, and the transportation ways to bring this low sulfur coal to the power plants there was a liberalization of transportation of coal that made it possible to switch to better coal. So that's how people look at this policy. Now let me talk about something that is, I don't know how to call it. It's not a total failure or total success. It's a mixed failure. So it's a bit like the half-empty glass. That's the European emissions trading system for CO2, which was decided in 2003, started implementation in 2005, and the price, so you have the price in euros. Here we'll see the price in dollars in a minute, but the first phase went okay up to some point, but then actually they oversupplied. They gave too many allowances, too many permits on the market. So at some point, when people realized that many of these things were superfluous, the price of these permits collapsed. And another mistake was that there were several phases, and the first phase was to end in 2008, and the permits were not bankable, which means that those permits that you had not used during the time of the first phase had no value. You could not keep them and use them in the second phase. So of course, then the market collapsed because these things had no value at the point where they could not be used anymore. And so there were two reasons for this collapse, and that was pretty discouraging. So things started again in the second phase, and they said, okay, we'll be a bit tighter on the amount of permits, but then boom, there was the big recession, and so another collapse in the price because the demand for permits collapsed, and so that was another sobering situation. And so the price has remained slow until in the phase 3, they started to really think a bit higher, a bit more seriously about that. So now all the permits are fully banked, so you can keep them and use them at any time. There was a bit too much, perhaps, of free. I said free supply could be good in some cases. Too much of free supply can be a problem because essentially you are not making these industries pay enough. And so you are somehow keeping their profitability a bit too high. And so now they auction more of the permits, and they put, again, tighter caps. And also there were offset mechanisms, and they've been tighter on that. And so now the situation looks, so this starts in 2009. And so when you look at the situation now, it looks like we are going back to reasonable levels, but it's still not very high, actually. We are in dollars, we are around $25 per ton of CO2, which is not extremely high. Okay, so what are the lessons for cap and trade in this thing? So as I said, you need to adjust the cap and be flexible about that, possibly scrapping the permits that have not been used, so you could rebuy them and eliminate them from the market. You should have this banking thing, so unlimited validity of permits. And you should probably set a price floor and monitor the price volatility, right? So you should avoid that the price could go below a certain level. As I said, you should auction a substantial proportion. And another thing is you should avoid auxiliary regulations that can impose additional constraints on these industries and that have no impact on the total thing, because the total thing is determined by the cap and trade mechanism. And so if you impose these extra regulations, it will not change the impact on the target, which is the total thing, but it will somehow distort the cost, the distribution of the cost between the agents, and this may not be a good idea. So the key element here, when you look at the curves of the curve of the price for the ETS, is really the price floor idea. So there is an obvious idea to deal with that, which is not to do a cap and trade mechanism, but to use a tax. Because when you use a tax, well, you set the price, and so you get to decide what the price will be. You don't have to worry about fluctuations of the price. And fluctuations of the price, this is something that is quite important for investors. It's very bad when you have to make an investment for a facility that will stay for 25 or even up to 40 years, and you don't know what the price will be in the coming years. That's very bad. If you could really be sure of the evolution of the price over the lifetime of your utility, that's very important, right? And so that's something that is a bit problematic with the cap and trade mechanism. So surprisingly, now in the US, what's more popular is the tax idea rather than the cap and trade. And I wanted to highlight this proposal that comes from a group of conservative politicians and conservative economists, which is about a tax rather than a cap and trade, because of the considerations I just gave. And it's pretty smart in terms of, so it's a bit like the Green New Deal, but it's perhaps a little less known. They include a social aspect to it. They include the idea that the proceeds of the tax will be distributed as a dividend to every household in the country, right? And so that would help, because this would be a flat distribution. Everybody would get the same thing, which means that for the poor people it will be quite substantial, and it will reduce the impact of the tax for them potentially. In fact, about 3/5 of the population would actually benefit in terms of living standards from this policy. So it may be quite interesting to look at. Now, a key question is, how do you set the level of the tax, right? So what are the tools we have to decide the level of the tax? So to give you an example, this conservative proposal is associated to various groups, conservative and not conservative, but there is one linked to the World Bank that has produced a report led by Nick Stern. We've talked about Stern already, and Joe Stiglitz, that published 2 years ago a proposal for where the tax should be. And they said the range should be between $40 and $80 per ton of CO2 by 2020, and between 50 and 100 by 2030. So the range is large, but that gives you an idea of where they think we should be going. And so where does this number come from? So the most basic computation that yields this kind of number is doing just that. So what you do is the following, and I'll be focusing here on this example of the social cost of carbon, right? So what's the social cost of carbon, which corresponds to the tax that you would like to put on a ton of carbon. So what you do is you first choose a definition of a social objective, because you have to look at the impact over the long term. So you posit a social objective, and for instance, you can take, and that's what these people are taking, you take the discounted utilitarian objective that I introduced last time, and you say, okay, I'll use that as a way of measuring things. And what you do is the following. You imagine that there is 1 more ton of carbon of CO2 emitted now, and you look at the impact of that on climate impact, on climate damages, that reduce the living standards in the future and so on. Okay, so you look at the impact of that on your objective function, right? So you say 1 ton of CO2, what is the impact on my function W, my objective function? Okay, so let me call that delta W1. That's the variation. So the size of this box here is the change in W induced by a ton of carbon. Okay, so it's a negative thing. It's bad for the future, of course. We want to make the people now feel the pain of that, right? And so we want to compute the equivalent of that in terms of current pain. And this pain will be something that will impose as a tax to people. And so we have to somehow scale this in terms of equivalent current pain in terms of consumption. And that's what you do by saying, okay, what is, if I were to add or to take $1 from consumption today, what would be the corresponding impact on W, right? So $1 now, what does it represent for W? And let me call that W, delta W2. Okay, so let's assume it's this small amount here. And so you need to compare these two things, and then that gives you the amount. So the number, so you try to put this box inside this one, and you see it's a certain number of times you have to put it there in order to reach the same impact on W. And that gives you the answer. So the ratio of these two quantities gives you the equivalent in current consumption loss of the impact that a ton of CO2 has on the future through all the climate impacts. Okay? So does that make sense? Is there any question about that? That's the basic thing. Of course, you need to have a scenario to look at that and all that, right? So it requires a lot of work to do, but that's really the basic computation that you make. Any question with that? No? Okay, so in the second part of my lecture, I'll dig a little more into how the scenarios are built and all that. Okay, so very briefly, what's the situation in terms of carbon pricing in the world today? Perhaps one thing I didn't put in the slides, I should have put, is we are still at the world level subsidizing fossil fuel. The total subsidies, I looked up the International Energy Agency, total fuel subsidies still represent more than 6% of total GDP in the world today. If we scrap that, we would reduce emissions probably by about 30%. So the problem with fossil fuels is not so much that they are not taxed enough, they are still subsidized too much. So that's the first thing to keep in mind. But let's look at proposals in terms of taxing. So the thing that's interesting to look at, you have two things to look at. So of course you have the number of jurisdictions that do that. So you have national and subnational level and all that. What is the size of the emission pie that is covered by these pricing mechanisms? 20%, about 20%, and we are getting there. But it's pretty small. And what is the range of prices, right? So we want to look at the prices that we put on that. If we cover all of emissions, but with a price that is too small, it doesn't do the job. And so the range of prices, it's between $1 and $127 per ton of CO2 equivalent. And the amount of revenues that's raised from that is 44 billion, which is peanuts, if I may say. This is almost nothing. So here you have a distribution in the world of these various initiatives. I'll let you have a look at the details, and you have and you can look at the report in more detail. You have a look at the various details in the main regions where this is occurring. I'll say just one thing a bit more about this initiative here in the northeastern part of the US in a minute. But this is, so I'll go quick on that. You can look at that and have an idea that you have many things happening. But in terms of coverage, this is a bit more of the detail of how the coverage has moved over time. So this is hard to read, impossible to read from the distance, but when you have it on your computer, you can look in more detail. So it really started to take off in 2005 with the European ETS. So this is the European ETS system. And then you have other countries that came up. The large bar here is what China is planning to do in next year with its own kind of ETS system. So this is what puts us around 20% of coverage of emissions, right? So that's the dynamics. And in terms of levels of prices, that's where the thing becomes really sobering. So you have the champions here are the Swedes. So the 127 that comes from Sweden. If you look at the range of prices that was advocated by the Stern-Stiglitz report, between 40 and 80, well, we have a few countries there, a few initiatives there, not many. And here you have the breakdown of the things that are below. So that comes from below here, below 40. So the EU ETS is at around 25, as I said. And then you have all these things up to very negligible levels. And the local experience I wanted to mention is this one, the RGGI at 5. That's a Northwestern initiative, regional greenhouse gas initiative that includes these states. New Jersey is not in this initiative, but it's part of other initiatives. In particular, it's part of this United States Climate Alliance of states that is trying to supplement the lack of policy at the federal level in the recent years. It's also part of another initiative that you have on the previous slides, the Transportation Climate Initiative that is likely to start in a year or two, which is a sort of interesting policy. It's a cap and invest. It's not a cap and trade, it's a cap and invest. The idea is to put, sorry?
I just want to say,
yeah?
people might be interested that New Jersey is currently in negotiations to re-enter RGGI, so it might soon be back in RGGI, even though it's currently.
Oh, thanks. Okay, good. Yeah, and it's part of the TCI already. So, so the transportation thing. So the cap and invest idea is that the proceeds of this thing, so the auctioning of the allowances, so the cost will be paid by the fossil fuel providers, and the proceeds will be used to invest in clean transportation technologies. Okay, so this is what you have here, and you have the price. So you see the price is just, if I may say, with all due respect, ridiculous. Okay, so another interesting issue here, which is a matter of debate between serious people, is whether we should have a unique carbon price or unique carbon tax, or whether we should have something that's specialized for different regions of the world in particular. Should the emerging and the developing countries, for instance, have a lower price? So here you have arguments for and against a unique carbon price. So the main argument for is that it minimizes the total cost of abatement. So I won't explain that in much detail, but you can really think of it for yourself. If different marginal costs are incurred by different agents, you have a way to reduce the total cost by shifting the effort from the people where the marginal cost is high to the people where the marginal cost is low. Remember the example with my plastic bottles that I tried to sell you before. There was this idea that if you equalize the price, that was, I explained, it was the way to minimize the total cost of production of these bottles, right? So it's exactly this story. Another argument is that if you have a price that's very different in different regions of the world, there can be carbon leakage. So leakage is not that the scrubbers are leaking, it's that there will be some movement of economic activities, of emitting activities to the places where they are less punished, right? That's the problem. And there are arguments like if you link markets which are separated, that is beneficial for most actors because they can really trade where it's most advantageous for them. So these are the arguments for. The main argument against is that it doesn't take account of the fact that it imposes an excessive effort on the poor, and so we might want to actually differentiate the price so that the poor have a lower price to pay. So one way to do it is really to give them a lower tax. Another way to do it is to give them some subsidies that compensate, right? So some money that compensates for the price. But if you don't do that, then it might be that a different price might be the only way to go. Okay, so these are the main thing. Yeah, so I wanted to insist on this idea that the recycling is really important, and you can use the proceeds of a tax in various ways, including reducing other taxes which are distorting the economy. But you can also just use it to quell protests by interest groups and for political reasons. Now, I just want to briefly mention, if you ask yourself, what's my role in this? As an emitter, as a private emitter. So it's interesting because if there is a cap and trade mechanisms that covers the sector you belong to, right? So if there is something where households can participate, then the efforts you make will not affect, if you reduce spontaneously your emissions, that will not affect the total cap that is put on the market. And so you may be very virtuous. It has no impact whatsoever, because the only thing that happens if you reduce your emissions is that it will essentially reduce the price the permits, and that's all. And so the only thing that you can do to have an impact in this context is to buy some permits and to destroy them. Right? So perhaps not burn them because that would put some CO2 in the atmosphere, but to destroy them. Right? So that's the only way you can really have an impact on the total cap. When you have a carbon tax, yeah, individual efforts still make an impact. So you have to look at what's the context and make sure that what you do will not be destroyed or compensated by action somewhere else in the economy. All right, are we good with that? So this is what the basic things I had to say about instruments. Is there any question or comment at this stage? No? Yeah, everybody happy? Great. Okay, so let's look at integrated assessment modeling. So don't be too afraid. We won't do a lot of math. So this is a whole universe, and you have many people working in that. You have two categories of integrated assessment models. So you have the models that are very big, look at sectors in great detail, and that are used to build scenarios that are sufficiently detailed that they give some credibility to the futures we can imagine. And you have the linear models, which have smaller number of equations, and that are easier to use, that serve to determine the optimal tax and this sort of thing, right? Do cost-benefit analysis of taxes. I'll go very quick on the first category of models. I encourage you to have a look at this paper that describes the main shared socioeconomic scenarios. So SSP is for shared socioeconomic pathways, which have been used and are still being used by the IPCC in the assessment of possible futures. So they have stories, narratives built around 5 main scenarios. And so taking the green road is somehow the one that's the most virtuous in many ways, including inequalities. But they have other scenarios. So you have a kind of middle of the road scenario. You have a rocky road scenario, which looks a lot like what we are getting into at the world level. International rivalry, protectionism, unequal development, and all that. That might be where we are going. And you have an interesting scenario taking the highway, which is a sort of betting on innovation, betting on technology. So essentially we do nothing, but we bet that technology will save us at the end of the day. That's an interesting scenario. So if you look at this paper, they give you the emission trajectories for these various scenarios, and they give you in quite some detail the trajectories of the mix of technologies, for instance, for energy production between renewable and nuclear on one side, coal on one side, and oil and gas on the other side. So all this is worth having a look at, and they keep producing. It's a big consortium of people, and they keep producing papers describing these scenarios in many angles. So now they have migrations and inequalities and all that. Okay, now let me say a bit more about the optimization models, partly because that's what at Princeton we've been working on in my group, and so I can be a bit more informed about what's going on there and give you some examples. So how does that kind of model work? So it essentially has 2 modules. It has an economy module and a climate module, and there is a loop between them. So what happens? So you have the key engine of the economy, which is production, and production is largely determined by the path of population, so labor force, and technical progress, okay, which determines productivity. And production, of course, will lead to emissions, so that's the influence on the climate module. Emissions induce temperature change, which loop back to the economy because that induces damages on the economy. And that reduces consumption and reduces production. And so the damages are harming the production. And we need to have a way to evaluate that, as I've been repeatedly saying. So we need to have a social welfare evaluation. So there is a social welfare computation that's made and that looks at these scenarios. So social welfare is influenced by production. That gives the basic thing on consumption. And then we put, and so, I mean, you may be surprised that there is no direct arrow here between damages and social welfare. It all goes through the reduction in consumption in the model we've been looking at. And the model we've been working with here is a variant of these. So I'm really focusing on the models that Bill Nordhaus, the recent Nobel Prize, has pushed from last year, has developed himself. So you introduce a carbon tax. So what happens when you introduce a carbon tax? That induces some mitigation cost on the production sector, and that reduces, so it improves the emission side, so it reduces emission intensity of production thanks to these efforts, right? And so that somehow reduces the negative feedback between these two modules. And what we've been doing here at Princeton is to, so you see DICE is the global model that Nordas has produced. R is for regional, so he has 12 regions in the world. And in Princeton, we had the idea of creating a model we called NICE, which has nested inequalities. That's the NIR for, and which introduces inequalities within the region. So we have the rich and poor in our model. That was not the case very clearly in the previous models. And then what you have then is a new loop, which is that the damages, we have to look at who they fall on. Okay, are they harming the poor or the rich? The poor because they are more vulnerable, or the rich because they have more capital that's exposed to extreme weather events, for instance, right? And so it depends. So depending on the scenario we have on the impact of damages, inequalities will be affected, and inequalities will be valued in our social welfare objective. Okay, so these are the main loops. So I want you really to understand the basic logic of these loops. It's pretty intuitive, but this is really a very natural loop, and it's nice that it is developed in these models. So this is the only math I'll show you, but I've already shown it. Is remember the discounted utilitarian objective. So what we have in our model is this. This is the objective, and so the CIT is the consumption at a unit level. So a unit is a region and a quintile within a region. So we split every region in 5 quintiles from rich to poor. And so that's the little I here, and T is the time. And so this, we have a scenario for every policy. We have a different path for this consumption at the quintile region level. And we put that in a utility function. So we have this eta parameter, which represents how curvy our function is. So the greater eta, the more curvy the function. So this is at the per capita level within a quintile. We multiply by the number of people in that quintile. And we have this pure discount, time preference term here. And we just add up over all these people time units. Okay, so the key parameters we have to choose in these functions are the rho parameter and the eta parameter. And the path of CIT is determined by the model, right? So you have the growth of production, technical progress, and all that goes through the model. And the values for the parameters that we'll be talking about in a minute are these values, which are in the range of values which are discussed by people in the field. So you may remember from last time I introduced the Ramsey formula for the discount rate on future dollars. So if you go back to these parameters, the Ramsey rule corresponds, the Ramsey formula uses this rho parameter as the first thing, and then you multiply the eta parameter, the coefficient of inequality aversion, times G, which is the growth rate of consumption. But now we have inequalities in every region of the world, and we have different regions of the world. So now the growth rate that we are looking at, well, maybe we have actually different growth rate when we compare people now and people in the future. It depends on what kind of people we are talking about, rich, poor, what kind of region. So we actually have implicitly different discount rates for different impacts of policies. Does that make sense? Any question on that? No? Okay. So now we have some time to look. So there is a climate, we've developed a very simple teaching tool that anybody can use, a climate policy simulator. And you can play with it, and I encourage you to play with it yourself during the break. Somehow it's a good time. And you can look at the impact of these parameters, time preference, and inequality aversion on the policy that's decided. You can look at what kind of policy or what kind of parameters will lead to a temperature that remains below 2 degrees. It's not every policy that does that. You can look at when we decarbonize completely, so when do the emissions go to zero. And you can ask also what would be the policy if the Trump administration believed in this model? What would it choose as a policy? And that's a bit tricky, but the hint I want to give you is look at the slide that follows this one. You have to imagine you use the Ramsey formula to get a 7% discount rate. right? So how can you get a 7% discount rate with the parameters that we have? The growth rate in the model is about 2%, so you have to combine rho and eta to get 7% with this given G. Okay, so let me now try to get directly to this thing. So this is online, you can access it yourself. And let us start this simulator. I will go quick together. What I'd like to do in the remaining time is really to play with it a little bit. And I will ask you the question that we ask people here. So if you have the choice, so you can start using your clickers here. And let me try to put that somewhere here. Yeah. So the question is, the government can save 100 lives now or 200 lives in 50 years. What option would you favor? Okay? So I'll show the results right away to see where we go. There is no harm in... Okay, so option A is... yeah, that's a bit big. Option A is this, and option B. So where are we going? Option B? So let's say we are selecting option B. Okay? Okay. Now you have you have to follow up, right? So now if the choice is between 100 now and 150 in 50 years, are you sticking with B or are you going for A? That's the question. Are we going for A now? Hey! Okay, so let's say we are going for A, yeah? Of course, you can disagree of that. I'm just taking a poll here, and you can play it with it yourself later. Sorry, it's not working now. Yeah, okay, good. Now, here is a question which is, so you see this first question was about time preference. Now, second question is about inequality. And inequality is about the following kind of situation, where you had a drought and you had land that has really been exposed to destruction, and you can send an agency to restore this land. The problem is that one part, the yellow land is easy to restore, the blue land is hard to restore. And so if you want to really restore the same amount of land in the two parts, so imagine you have two categories of farmers, two populations there, you can either do that equally, but you have to put a lot of money on the blue land, and that you get a certain amount of land that is saved here, 80 acres, or you can go where it's easier, and so then you can save 100 acres, but it's more unequal. So the guy with the difficult land only has half of his land restored, or 20, I mean half as much as before. So the question is, do you prefer the more efficient thing or the more egalitarian thing? That's the question. Okay, so continue clicking until we see where you want to go. Are you going for A or for B? Okay. Okay. You are gaming me, I see that. So let's say it's A, right? All right. Never mind. That's fine. Okay. So then let's continue. Now we have same thing, but now it's the efficiency loss is less, right? Here we have 45, and 45, before it was 40-40. Here it's the same, but now it would be actually less of a loss if we went for the egalitarian solution. So what would you choose then? Oh, now we seem to have a preference for B. Yeah? Is that the case? Yeah? Okay, wow, that's even quite a preference. Okay, I really like the joke. Okay, now, here is the same kind of thing, but you have to to do it again, and that is a bit harder. So you have A, B, C, D, E. You have to choose, so I'm not quite sure what you should be doing here. In order to save time, I would recommend, because this is done for the following purpose. The idea is to check that people are not completely crazy in their answers, and so that the answer to the second question, which is giving a series of options which are a bit similar, they are consistent. So if they are not consistent, we force them to do it again. So I think that given what you've done, probably you should be selecting this option if you were consistent with your previous answers. I hope I'm right. Let's see how it goes. Yes, so that's what it says here. So now I can remove that. So thanks for your participation. So you have implicitly adopted a rho parameter equals to 1% and an eta parameter equal to 1. Okay? So that's where we go. And so when you have done that, so please stay for 1 more minute. You continue and you get the results. So yeah, we can now look at what the results are. So how do you see the results? Then you get something like this, which gives you the evolution of the carbon price. And so you have the choice between different scenarios, and you have the explanations on the website. You can have different climate impacts, high, low, medium, and you have the distribution of impacts on the poor and the rich, which is also an important parameter. One thing I want to explain before you leave is that, so this is the price of carbon that we have for this policy. So it's the optimal price given our objective, given your objective. What may look weird is that it goes down here. So why does it go down here? Well, because the improvement in the cost of renewable technologies makes it the case that at some point, when the price of when the carbon tax is too high, we completely decarbonize, right? And so the improvement in the lower price in renewable technologies makes it the case that in the future, we need to have a lower tax in order to get full decarbonization. And so that's why it is decreasing. So it means that we no longer need that much tax in order to keep full decarbonization after some point, thanks to technical progress, reduction in price of renewables. Okay? So you have a few additional slides that help you understanding how this works, but I really encourage you to play with this climate policy simulator, and wish you a good break, and thank you for being here this morning again.